Welcome back. This is step 3 of our chapter 2 ladder review. In this video we're going to be looking at polynomial functions and how to put them in factored form. So in question 1 here I am looking at this particular polynomial function and it has some zeros. Looks like we have a 0 at negative 5, 0, 0, 0, and 3, 0. And there's a couple things, if I'm going to write this in factored form, there's a couple things that I need to look at. First of all, the end behavior, both of these, as x goes to the right and as x goes to the left, are pointing down to negative infinity. So that means I have some reflection over the x-axis. So this function is going to have a negative on its leading coefficient. And the next thing that I want to look at is at these zeros, these x-intercepts. And when I'm looking at these, there's something really interesting. Both negative 5 and negative 3 cross through the x-axis, but our 0 at 0 does not. It touches. So the thing that I'm hoping you will recall here is that if I have a 0 that crosses through the x-axis, that has an odd multiplicity. And I'm guessing that this is going to be a multiplicity of 1 rather than 3 or 5 or something like that. And same over here. Now, when I'm looking at this, if I look at the number of turns, it looks like there's 3 turns. So 4 minus 1 would give us 3. This is going to be some sort of 4th degree polynomial. So if these are multiplicity of 1, as you might have guessed, anytime I have a 0 that touches or bounces on the x-axis, that has an even multiplicity. And so for us to get to 2, or to 4 rather, as a degree, we have a multiplicity of 2 for 0. Now to put this in factored form, normally we put the 0 at 0 out front, and it has a multiplicity of 2. And also let's keep in mind our leading coefficient is negative. So what I'm going to do here is I'm going to say that this is going to be negative x squared times, I have a 0 at negative 5. So in factored form, that's actually going to be x plus 5. And I have a 0 at 3, so in factor form, that's x minus 3. I'm going to say, let's take a look at this function. So using my graphing calculator, I'm going to take a look at this. And we hit the y equals button. That gets us to this page. I'm going to say negative x squared times x plus 5 times x minus 3. I'm going to hit graph. And the first thing I notice is that the graph that we just put in is much taller than the graph to the left. Now granted, we don't really know exactly what kind of window we're looking at here, but I see that this local maxima is quite a bit closer to the x-axis than what we have here. So that means I'm going to have some sort of shrink compression here. So I need to say, okay, let's go backward here and say I want to insert a fraction. Let's say, how about 1/4? Less than 1 would give me this shrink, so I'm going to hit graph again. And already I can see that this is quite a bit better. But still not quite as low as this is. Again, I know that we can't really see what the view is here, or the window is for the graph on the left, but I think we can get a little bit closer. Let's say, how about 1/8? And again, we have this looks a lot better to me. Again, if I were to zoom out of this window or change it so our y values were a little bit farther out, like negative 20 and 20, something happened here. 20, not 2. Let's graph that again. That looks like the graph on the left. And so we can see even just changing the window sometimes changes what we can actually see. And so this looks a lot better. So I'm going to say I think what we have here is correct. So I'm going to actually cross this out. It was close, but not quite. Say we have f of x equals negative 1 over 8 x squared times x plus 5 and x minus 3. And that is a polynomial function in factored form that could create this graph. Next I'm going to look at number 2, and number 2 is very similar in a couple ways. When I look at again, give us the zeros, and here though they want standard form, not factored form, but to get to standard form we're going to need to be able to put this in factored form. So I'm looking at this and saying, okay, if I have a 0 at 0, that in factored form is going to be out front. If I have a 0 at negative 2 in factored form, that's going to be x plus 2. And if I have a 0 at positive 3 in factored form, that's going to be x minus 3 with a multiplicity of 2, so that's going to be squared. Now, some of you, if I'm going to get this to standard form, I'm going to need to multiply all of these together. You can go ahead and FOIL this if you're somebody that likes the FOIL method. Personally, I really like to use Punnett squares to multiply these because when I do, I can see all of my steps and I can see if I made a mistake, I can go back and look and see what I did wrong. So that's the method I'm going to use, but again, you don't have to use that. So I'm going to take care of this piece first. I'm going to multiply all these pieces together. So I'm going to use a little Punnett square here. And x minus 3, x minus 3. X times x is x squared. Negative 3 times x is negative 3x. Negative 3 times x is negative 3x again. Negative 3 times negative 3 is positive 9. And if I take all of these pieces out and combine like terms, that gives me x squared minus 6x, because these go together, plus 9. Okay, and so that's this x minus 3 squared. Here's that in standard form. Now I'm going to need to multiply that with this x plus 2. Again, you can FOIL if you're somebody that likes to FOIL. For myself, I really like being able to see all of my pieces visually, or all my terms visually. And so I'm going to do that again here. X squared minus 6x plus 9. Now in this case, because I have 3 terms multiplying 2 terms, 3 times 2 is 6, so I'm going to need 6 boxes in this case. So 3 by 2. And I do the same thing. X squared times x is x cubed. X squared times 2 is 2x squared. Negative 6x times x is negative 6x squared. Negative 6x times 2 is negative 12x. 9 times x is x. 9 times 2 is 18. And I combine all of those like terms, and I get x cubed minus 4x squared, because negative 6 plus 2 is negative 4. And then the x's go together. Negative 12x plus 9x is negative 3x, and plus a positive 18. Now, altogether, I've multiplied these 3. So I have x minus 3 times x minus 3 times x plus 2. I multiplied all that together, which gave me this. And last but not least, I need to multiply all of those by x. So I'm going to have that f of x is really equal to x times everything that I just got. And as you may be able to guess already, x times x cubed is x to the power of 4. I'm just using a distributive property all the way across. And that's going to give me negative 4x cubed minus 3x squared plus 18x. And there is the polynomial function in standard form using these zeros.